In 2022. That's this year. That's right now. What's the proper way to get into machine/deep learning? By getting into machine or deep learning, I mean, this is what they mean, okay? Building up to a stage to do machine learning, deep learning research, applied research or core theory of machine learning, deep learning research. Of course, man, what? I didn't know these compound words existed. The path to both will be quite different. Standing in 2022, what are the best resources for a CS student/decent programmer to get into the field of ML and DL on their own? Well, if you're a student already, just take more classes? I don't know. I feel like classes, but let's see. The target ability to understand theory behind the algorithms, to implement the algorithm on a data set of choice. Data cleaning and management should also be learned. Read research publications, try to implement. So this person just wants to be like, this person's literal answer is go to school. Like, is that wrong? I'm trying to think about this from the perspective of like a psychologist or a neuroscientist, right? Like me, who went through psychology and neuroscience. If someone said, if you replace all these words with like, oh, like, how would me, a student in psychology, go about learning about neuroscience? I want to understand biology. I want to be able to conduct my own research. I want to try to read publications and implement them into new experiments. The answer is go to grad school. Like, it's not like a go to grad school. It's not like that. It's like, that's the only place you could really learn all of that, you know? Like, that's the only place where you could have time dedicated to learning all of that information in a way that you could ultimately do those things. You know, understand the theory, be able to do experimentation on your own, be able to at will manipulate information, not manipulate, but be able to produce or verify or create new knowledge. That's really the only place, you know? My 2 cents. Not exactly for what you want to do, probably. 1, get some statistics, probability basics. It's full of people, as you can see a lot of analyses on Kaggle, that do machine learning, quote unquote, but make very silly mistakes. Turn categorical data into float and use it as a continuous variable when training a model. That's a very good example. That's very specific. Take a look at traditional machine learning approaches. Nowadays, you're swamped by DL. A lot of good suggestions. I won't chime in. And you miss the fact that sometimes a simple decision tree or dimensionality reduction approaches can yield incredible value in very short time on huge data sets. I'd written a fairly short post about it when I finished my Georgia Tech path. It can take a lot of time to become effective in machine learning. Effective as in what you manually create in markdown italic is as effective as picking an existing trained model, fine-tune it, and use it. In general, this doesn't actually happen. This actually doesn't happen. This can be frustrating. Low-hanging fruits are pretty powerful, and you don't need to understand a lot about ML algorithms to pick them up. Consider online classes. I took Georgia Tech OMSCs, and I can vouch for it, and some classes force you to be a data scientist and read papers well, and you can have real-world recognition and discuss with your peers, which is useful. I'd say for the most part I agree about all of this info, and I'm glad this is there like some upvote mechanism here? I guess so. I would assume that this is probably one of the more reasonable answers, because it does answer some of the question. How could you do it on your own for the most part? And there does exist a resource, unlike neuroscience and psychology, where people are actually doing data science openly, anywhere from simple to complex forms. That exists online on Kaggle. That exists online in many forms, not just Kaggle. But Kaggle's a great one-stop shop for data sets, notebooks, discussion. GitHub does have some of these things. They just don't have a tied together community aspect that they force. A lot of the time it's just data repo or file sharing of some sort. And of course you can find communities like ours, which do a lot of what Kaggle does, just in a very DIY way, not centralized or large or as generalized as a lot of the things on Kaggle. So at the very least, the idea that, one, you could actually learn statistics and probability to some extent on your own, and two, it's actually possible to get a lot of not just inspiration or ideas, but a lot of education or new knowledge from a place with literally hundreds of thousands, if not millions of relevant notebooks for you, let alone like tens of thousands of most likely relevant data sets. It's very easy to find your way into that community and start learning very quickly. So this is not a hashtag ad either. This is just true, right? We do that a lot here, right? This is just something we do here, you know? The issue is, like, to do all of these things and to do it in a way that this person's sort of describing, which is, like, one, this person's building up to a stage to do this stuff. Building up to a stage. So does that mean learning, or does that mean they want to be competent at the end of it, right? Because if you just want to learn a bunch of shit, okay, let's just go out and learn a bunch of shit. That's fine. That's an open market for you. But if you want to go out and like learn and also have like some sort of expertise, I don't know if you could get that completely on your own. You're going to need like a community or someone that's invested in you as like a mentor or an advisor, which is why, again, me as a person who actually does not like higher education or academics at all, I think a lot of the experiences in terms of mental health and physical health are just not worth it. But also, as a person who's benefited from higher education, I do know that if you do it right, with the right people around you, with the right advisor, you can get exactly what you want and be a person who has expertise, right? Now, the second side of this is if you are a person who's interested in working your way and learning this along the way, there's a lot of entry-level opportunities for someone who is coming out of school as a CS student to be a data scientist at the entry level if you have some rudimentary or basic knowledge of statistics and being able to apply that information in analyst or engineering type ways. It's not impossible. It's not impossible to think that you out there, a student, can actually find this information and also make money while doing it. That's just called having a job. There are many different ways to do this. Either you can go online and learn it for yourself. You could go out back to school or go to graduate school and learn these skills and make sure you have a good like system that allows you to stay informed and stay up to date on relevant pieces of information about data science, and make sure that you have people who support you in your efforts. Or you could get a job that requires you to be good, and then you will inevitably have to learn all of these things because it's a requirement to keep your job. All three of those paths are probably good, and all three of those paths are very well trodden. So I would say, if you're interested in knowing more about any of those paths, you could ask literally anyone in chat. You could ask anyone in the Discord, !Discord. You could ask anyone. And of course, you can ask me, Nick Wan. I actually switched majors from statistics to data science because the data science degree is teaching actual programming instead of theoretical methods. A lot of people do that. Like for me, I switched degrees from chemistry to psychology when I was an undergrad. The reason I did that was because someone told me that research and instrumentation, which is what I like doing in chemistry, was a lot of what you could do in psychology. It's just applied to people as opposed to doing something on chemicals and getting back chemicals. So I was like, yeah, I'm going to change what I'm doing and completely go towards psychology if it's essentially all the same stuff I like, which was instrumentation and analysis. And in this case, instrumentation and analysis was EEG and doing shit in MATLAB and then confirming results through statistics. Like, that was all very cool to me. Here I am several years later, over a decade later, and I still do like instrumentation analysis, but my instruments are player tracking on a baseball field, biomechanics and biometric data. My analysis tools are still basically the same. I went from MATLAB to Python. And statistics, they don't change. It's fucking statistics, dude. You could choose whatever path, but so long as you have like something you truly enjoy doing at the STEM level, you could really do a lot of things, right? Like for me, again, instrumentation analysis was the thing I liked in chemistry. That ended up following me through psychology into cognitive neuroscience, from cognitive neuroscience into data science.